My name is Glenn Hawkins, and I'm the Senior Director of Product Management for Maximum Availability Architecture and DataGuard here at Oracle. And today, I'm going to bring you through Maximum Availability Architecture Blueprints, which are the reference architectures for reduced planned and unplanned downtime for the Oracle database. So to jump into it, first we'll go through Maximum Availability Architecture, the fundamentals, as well as how it evolved over the years. We'll explore the different MAA tiers, and then we'll look at the MAA in the cloud and all the automation that Oracle offers there, and finally open up to questions and answers. So let's start with how Maximum Availability Architecture evolved. Now, before we actually jump into the specifics, it's important to understand the problem that we're trying to address, and that is database downtime and data protection. We don't want any data loss. And the impact of both of these type of occurrences can be significant, as we can see from this slide. $350K on average cost of downtime per hour, 87 hours average amount of downtime per year is pretty significant. So it's a very, very common occurrence. $10 million for a single outage, depending on how critical the application is. And 91% of companies have experienced it in the last unplanned data center outages in the last 2 years, which means this occurs fairly often. So if we look at how we're going to go ahead and address this, it's important to understand different terminology first. So we'll start with high availability. High availability provides redundant components to go ahead and ensure your service is uninterrupted in case of a type of hardware failure. So if one server goes down, the other servers will be up. Ideally, you have a cluster to go ahead and provide that level of redundancy. And then we talk about scalability. Depending upon the workload, you want to ensure that you still have your performance. So as your application becomes more popular and more end users go ahead and join it and the workload increases, you want to ensure that the performance is not impacted at all. Rolling updates and patching. So if we want to go ahead and minimize the time that we for our planned maintenance, which happens a lot more often than unplanned outages, we need to do so in a rolling fashion. And that's where rolling upgrades, rolling patches, all these type of features come into play. Disaster recovery. So we move from high availability to disaster recovery, protecting us from a complete site outage. So if the site goes down entirely, we want to have a redundant site to be able to fail over to. And that's where disaster recovery comes into play. And then how do we measure downtime and data loss? So we do so with recovery point objectives, or RPOs, measuring data loss, and recovery time objectives, or RTOs, measuring our downtime. Now, how is maximum availability architecture? How do we actually create these blueprints and reference architectures? Well, we use a technique called chaos engineering. Essentially, it's an art form at the end of the day because constantly evolving and changing over time. We're proactively breaking things in the system, and we're testing how our failover, how our resiliency, how our switchovers, and how everything goes ahead and works under the covers with all our different features. And there's a lot of different components that can go out. Here's just kind of a sampling. We have networks and servers, storage, called all these different components can fail, but also human error. Someone could delete a table, they could delete a bunch of rows. So they can make a mistake on the system as well. That occurs very often. Data corruption, and then of course, power failures. Godzilla could attack and take out the entire data center. And then you want to be able to go ahead and have disaster recovery in place. And then there's all kinds of maintenance activities that happen with application updates. You might want to reorganize the data without changing the application, and then small little optimizations. And these can all happen in isolation or in combination with each other. And so chaos engineers to take all this into consideration and build out the use cases to go ahead and test the system. So what is maximum availability architecture? Well, it comes from the customer insights and expert recommendations from customers just like yourself. We've gone ahead and collected these over 20 or 30 years. Over time, a dedicated team of 40 plus engineers, some of our veterans at Oracle have gone ahead and taken on using these chaos engineering techniques to go ahead and test our architecture in the cloud, on premises, and then all the different types of failover. And we've gone ahead and built all these expert recommendations. And we've gone ahead and aligned them with 4 different tiers, 4 different reference architectures going from bronze, silver, gold, and platinum. And they all map to different RTO and RPOs, depending upon your requirements of your particular application, which is probably different between the different applications out there in your organization. And then those map into 4 different categories that we focus on: continuous availability, data protection, active replication, and scalability. And you'll notice some of your favorite features: application continuity, RAC, Active Data Guard, Flashback, RMAN are all in here, and they overlap together. Some of them overlap over different categories and they integrate together. And that's another key part of this. These are all integrated technologies. But it's not just the technology that goes ahead and defines MAA. It's also the configurations and operational best practices represented by our different documentation and our papers out there that go ahead and provide those best practices to you. And then we have a bunch of different deployment choices that you can go ahead and use. And we test all of them: generic systems, engineered systems like Exadata, and then our DBCS, XSCS, XSCC as we go ahead and build onto the cloud, all the way up to autonomous database, where we're going ahead and applying these best practices for you. We're going ahead and using these technologies, we're configuring them. It's all managed by Oracle at the autonomous database level. So that's MAA. And if we look at how this might map into your applications, as I mentioned, the tiers go ahead and map to different RTO and RPO values. So if we go ahead and look at them, we just have, these are not a one size fits all. The whole goal is not to get all your applications up to Platinum MAA. The goal is to go ahead and map them to your requirement. For example, Bronze is very suitable for dev, test, prod, single instance database. It's restartable. From an RPO standpoint, it's usually using backups and restores. And then as far as Silver goes, we build out our high availability. And this might be suitable for your production, like less critical production, maybe departmental. And it introduces RAC. So we have clustering in the picture at this point. We have application continuity, which we'll discuss here in a moment. And then as we go ahead and build that out to our more critical production apps, maybe customer-facing applications that are business critical, we build on that to Gold. And when I say build on that, notice the Bronze plus, Silver plus that you see in these different tiers. They're built on one another, supersets of one another. So we're constantly building out. So in this case, in Gold, we have disaster recovery in the picture. We have a redundant site that we can go ahead and fail over to, protecting us from any kind of site outage. And then Platinum, for those that require an RTO of 0 and an RPO of 0, Platinum's where it's at. And these take into consideration both planned maintenance and unplanned outages. So these are the different configurations that you can go ahead and apply. These tiers build on one another. They're designed. You could start with Silver and you could build out to Gold and then expand to Platinum at a later point. A lot of applications start out at one tier, and as they start to become used, they become more critical to the organization. You may go ahead and expand them to other tiers. You may go ahead and add a redundant site. You may go ahead and add Platinum. Okay, let's go ahead and explore the different tiers and where we're at with them. So we'll start with Bronze. Bronze is the foundation of all the other tiers. We start with a single instance database. We can see we still have a second availability domain, which represents another data center fairly close. We can replicate backups to. And RMAN is at the core of this. So we can go ahead and provide our backups. We also have ASM. We have multi-tenant as a core technology here, depending on which version of the Oracle database you're running. And then key technologies like online operation maintenance, and that we have flashback technologies also available here. And if we look at our different, if we look at our matrix here, we can see the different RTO and RPO values that represent different type of outages or planned maintenance events. So recoverable node, minutes to hours, disaster, well, we're recovering from usually from backup at this point, unless we're using our recovery appliance, ZDLRA, which is an optional component here in the Bronze architecture that you can go ahead and utilize for all the tiers. With that, you could get an RPO of 0. From a planned maintenance standpoint, minutes to hours, both for upgrades as well as patching in this tier. So we already get a very nice foundation that we're going ahead and building from. And as we go ahead and look at the different technologies there, we'll start with multi-tenant. Now I'm just going to go ahead and highlight a few of the features, not all of them, but multi-tenant provides a lot of capabilities. And we recommend as you go to 19C now, that's the time to go ahead and uptake it if you haven't done so already. Moving forward, as you go from 21C and beyond, you will always have at least one container and one PDB. It's part of the core architecture moving forward. So 19C is a great time to go ahead and look at adopting that. And it provides a lot of capabilities. The rapid cloning and provisioning. You can manage many as one. Configure data guard at the CDB at the container level, and it will apply to all the PDBs that are running within that container. It provides a lot of improved agility for development teams, setting up test environments, compatibility. You can go ahead and unplug a PDB from one container, plug it into another. Enhanced security, you can separate duties. You have resource isolation. So it's very, very good technology for consolidation as well. And of course, it integrates with all the other high availability features that we have like RAC and DataGuard. So let's take a look at some of the advantages and the way it works. So we can see we have our container database, and then we have different PDBs, maybe representing different applications that are running on top of it. We can go ahead and easily rapid provision these things. We can clone them. We have the ability to go ahead and from manage many as one, we could also easily upgrade these by unplugging a PDB from one container and plugging it into an upgraded container. We have granular control wherever it's appropriate. And then from a consolidation standpoint and resource standpoint, we shared memory and background processes. So you can take advantage of that very easily. So multi-tenant provides a whole bunch of advantages that go ahead and kind of build up that Bronze foundation. Now, the other technology I want to highlight from Bronze is our flashback technology. Most people think of it as a rewind button for the Oracle database. You create restoration points and guaranteed restoration points. It's a point-in-time recovery solution. So you could do so with the entire database level. You could rewind the database, but it's actually much more powerful than that. And if we look at the use case that we have here, where somebody has accidentally given a promotion to everybody in their company up to VP, it's almost comical. But if you think about it, if this table is tied to security, this could go ahead and cause quite a few problems. People could have privileges that they shouldn't have and access they shouldn't have. So you want to go ahead and you want to resolve it very quickly. But you don't necessarily want to go ahead and rewind the entire database. You certainly don't want to have to restore from backup if you can avoid it. Flashback has both the kind of the physical flashback capabilities at the entire database level, but also has logical flashback capabilities. So you can back out a single transaction, or you can go ahead and back out, flashback a single table using flashback table functionality. So we can go ahead and just flashback that one table, and we're back up and running. So very powerful technology, very unique to the Oracle portfolio. Now this takes us up to Silver. So with Silver, we're getting high availability. We have clustering at this point with RAC. I'm going to talk about RAC here in a moment. We also get the application continuity capability, which is a very critical technology. And certainly if you're on 19C, you should always be using it with RAC as well as Active Data Guard, which we'll talk about in a moment. So we have our diagram there. We can see it's very similar, but now we have RAC in the picture within our primary availability domain to take advantage of. And we can see instantly our recoverable node, if any of those servers were to fail, another node just picks up. So we're talking about single digit seconds or even zero with app continuity in the picture, which we'll talk about how that works in a moment. From a planned maintenance standpoint, we can now do rolling patching as well. And we get zero downtime associated with that as we go ahead and roll through the different nodes. All the rest of the different pieces from a disaster standpoint, we still don't have DR configured. And we're still not going ahead and configure to handle database upgrades from a minimal standpoint. So we're mostly talking about patching at this point. So let's take a look at the different technologies here. And we'll start with RAC. So RAC, as we said, is a clustering technology. You spread your different nodes across the different servers, so you don't have a single point of failure. From a scalability standpoint, performance standpoint, you get a lot of benefit associated with that. You constantly add a new node whenever you want to without experiencing any downtime. So you have that flexibility at this point. In any type of outage occurs, all the committed transactions are going to be protected. And we'll go ahead, we'll move that session over to a new service. So from that point, we want to go ahead and also protect our in-flight transactions. So in-flight transactions, how are we going to protect those in addition to the RAC nodes? Well, we can go ahead and do so with another piece of technology that's built into RAC, and that's the transparent application continuity feature. So this feature is going to expand the capabilities of RAC. It's a feature of RAC to go ahead and protect our in-flight transactions. So our application doesn't experience those transactions failing and coming back up to the layer or even up to the end users. We want to capture those. We want to replay them. So that's what application continuity does. It allows us to go ahead and do that. It supports a whole bunch of different technologies from Java, .NET, PHP. You don't have to make any changes to the application. All you have to do is use the correct driver and have the connection string appropriately configured, and then everything else is happening in the database. The Oracle database will take care of the rest of it for you. In both RAC as well as we'll talk about later in Active Data Guard. So this goes ahead and will turn a blackout event potentially for the application with all those transactions failing into a simple brownout. They'll just small performance hit, and then those transactions will replay, and the result will go back to the application as you'd expect. All right, that takes us up to Gold. In Gold, Active Data Guard, so disaster recovery comes into the picture at this point. It also, I like to highlight the fact of why MAA is not just a technology, but also how the configuration best practices around that. You can see that represented in the diagram. So active data guard, as I mentioned, is providing replication, providing our DR, has different protection modes associated with it. And we have a primary region, a secondary region. Think of them maybe either hundreds of miles or thousands of miles apart. So network latency is going to come into play on these with the replication. What you'll note here is that we have a local standby and we have a remote standby. So local standby is in an availability domain, essentially a data center sitting right next to the primary. It's very low latency, under 1 millisecond ideally. And we have fast start failover configured between the two. So we'll automatically go ahead and fail over to the standby. That replication is happening synchronously. You get zero data loss associated with that. An acknowledgement is going back to the primary every time as replication, as redo is replicated over to the standby. And then the commit does not happen on the primary until that replication occurs and you get that acknowledgement. With the remote standby, it's too far away to go ahead and do the same thing. If you wait for the acknowledgement, you're going to get a performance hit on the primary. Now, that might be suitable for some applications, but many, you can't wait for that. So we set up that in asynchronous protection mode instead, maybe our max performance mode. So this will go ahead and asynchronously go ahead and push the redo over to the remote standby, and you could experience a small amount of data loss. Now, you can see that represented here in our RTO and RPO. From a disaster standpoint, we're talking seconds to 2 minutes for that role transition. Your RPO is 0 for our local standby. So if we have something go wrong with the primary rack cluster, it can go ahead and fail over to the local, and you will get 0 RPO. If the whole site fails, so Godzilla attacks, takes out the entire site, or you experience this huge power outage and you can't recover the environment, at that point, you may experience a slight delay in the redo, and you might have open yourself up to a small RPO of seconds or milliseconds. So very small. This is how you can get your cake and essentially eat it too without affecting the performance of your primary. And then we also have the ability to go ahead and do upgrades now with our DBMS rolling feature to allow us to go ahead and roll through we can turn one of those standbys into a transient logical standby. We can do the upgrade against it. The experience, the 30 seconds that we're talking here, is essentially recycling one of those servers as we go through. And as long as you have more than one standby, you still have your DR configured as you go ahead and run through this. And a lot of our customers also have a second remote standby for this exact purpose, so they can go ahead and kind of roll through them. So they have 3 standbys associated with that, just so they always have a remote and a local that's staying up and connected up, doing physical replication when they go ahead and switch one of them to a logical transient to go ahead and configure and do the rolling upgrade. So let's take a look at some of these technologies. So we'll start with essentially the data guard functionality. So data guard is very different than storage remote mirroring, right? So storage replication essentially replicating everything on the drive. So everything on the server system. So if someone deletes a file on the server, guess what? It's going to replicate that over to your secondary sites as well and potentially go ahead and corrupt the environment. Not ideal. Data guard doesn't do that. Everything's happening in memory and it's just pushing the redo. So only the redo is going over the wire. So you're getting a lot less network traffic. We have a lot of different protection modes that you can choose from for synchronous and asynchronous, as we were talking about before, to go ahead and give you that flexibility that you need and to give you that protection you need. We also do a ton of block validation associated with all the different redo that's coming across as well. So there's a lot of validation built into it. That's really designed to go ahead and protect the database the way it should be protected. And that's why we created Data Guard. So why is Active Data Guard recommended instead of Data Guard in MAA? Well, Active Data Guard has a lot of different features. It's very well known for the ability to go ahead and offload read mostly. We used to say read-only workload, but read mostly workload, because you can have the occasional insert or update now with our DML redirection feature in 19C. So you can open up the standby and it doesn't sit idle. You can have workload against it, move that off the primary. You can also go ahead and offload backups. It's the actual physical replicant of the primary, so we can go ahead and take a backup from it. We have DBMS rolling. All these type of features are available to us, but none of these features are the reason that it's required for MAA. It's the advanced data protection that's provided by the app continuity feature that's built into Active Data Guard, just like RAC, and the automatic block repair feature that automatically, if you have any type of block corruption that occurs in either the primary or any of the standbys, it will automatically go ahead and copy that block over from one of the other servers. It'll copy it over from standby to primary or primary to standby to correct that. You just get a little note in your activity log and it takes care of it for you. That level of data protection in the in-flight transaction protection is why Active Data Guard is required as part of MAA. So let's go ahead and build on that to get our zero RTO and RPO with Platinum. So all the technologies, RAC, Active Data Guard, Flashback, all these technologies are still available. RMAN's in there with our backups. So we see all these represented in our diagram. We also see two primaries. So now we have an active configuration. We could also do active passive between those two primaries, with Golden Gate being the technology that's providing that bidirectional replication, which is asynchronous in nature, which is very, very important to note between those two different regions. So now we have two primaries. We could split the workload between them, but we might have to think about some conflict resolution between those primaries. I like to use the example of sequences, which is a pretty simple problem to fix. You can have even in one of the data centers, you could have odd in the other to go ahead and simplify that. But since it's asynchronous in nature, you have to be aware of this type of conflict resolution. We also don't have features like application continuity in Golden Gate. And we need that synchronous replication to happen to go ahead and give us that RPO of 0. Thus, we have Active Data Guard, we have standbys, local standbys in both data centers as well, with fast start failover configured between both of those as well. And we have our backup set up. We can see this represented here in our recoverable nodes. We have 0 single digits for recoverable node perspective. Disaster 0, all our different planned maintenance, because we can go ahead and upgrade one site without impact to the other. And we can go ahead and have, from an active standpoint, we have both sites up and running. From an active passive, we're one load balancer click away. And that's kind of represented here in as far as the different RTO and RPO values. But most people's goal is to get a zero RTO associated with that. So we already had a 0 RPO in our Gold MAA, which we're carrying over to Platinum. Now, Golden Gate's not the only technology in the Platinum MAA tier. We also have sharding and we have edition-based redefinition. So sharding is horizontal partitioning. It provides different shards, which is a database instance of its own, which could have RAC and Active Data Guard applied to it. It allows you to go ahead and you essentially have the same columns in each one of these shards, but the rows might be different depending upon a sharding key. So you're isolating the data. So you have basically a fault isolation between them. You could also distribute the data geographically. If some data has to stay in certain regions, you have that capability with sharding. And it provides a huge benefit to scalability as well. The EBR feature, or edition-based redefinition, we're going to talk about that in a moment. So that's for application upgrades. So it's a very unique piece of technology. But let's first talk Golden Gate and how we might go ahead and deploy this. So Golden Gate is doing logical replication at the end of the day. It can go ahead and pull data. It has a lot of flexibility going across different versions of the database. So it can go ahead and capture. We have trail files. Essentially, it's capturing SQL and carrying it over kind of the wire. And it's bidirectional in nature, and you can see that represented here. Now, historically, all these components would be running on the actual database systems with Golden Gate. But over time, we went ahead and created a microservices architecture or hub architecture. So all these components, all these arrows that you see, these trail files, are all now in the hub, which is very convenient because we want that hub to be deployed in high availability as well. You could do so usually with ACFS, is usually the technology you would use to go ahead and provide replication required to handle Golden Gate, right? So we have a whole paper on this that you can look in the MAA website that will walk you through high availability for Golden Gate, but that's very important. And we recommend this hub architecture for this purpose. The only components that are running on the database at that point are the log miner. That's it. Everything else will be running within the hub. The other piece of technology that I wanted to go ahead and focus on for a moment is our edition-based redefinition, or EBR. So this technology is very unique, and sometimes it's overlooked. People are not even aware that we have it. It's a very unique feature that allows you to do zero downtime or hot upgrades of your application, not the database, the application that's running on the database that's using different database objects underneath. And we do this using our edition technology within the Oracle database. So what you have your run, you can see in this diagram, we have a run app and a run edition. That's our current application. It's taking load, it's in production, and we want to go ahead and patch that application. Well, we can spin up some more servers, so for the application side, but those servers need to be going against the database as well, which had changes, maybe has new columns, new tables, rows, a lot of different changes that may have happened. Store procedures may have changed in the new version. So we have a patch addition running in the same database that patch application is going against. And they can run simultaneously together. Both applications are going, instead of going against the physical tables, they're going against additioning views, which might be different between those two editions, exposing and projecting different columns to the actual application against the same physical table. And we have a whole bunch of papers and presentations that walk you through all the ways that this works. Cross-edition triggers are propagating data between the two and allow you to have workload running against both your current version of your application and your patch version. And you can move users over to the new version of the application. You go ahead and connect the new clients up to the patch application, and you can use it simultaneously with your current version of the app. Eventually, you get comfortable to the point with the patch application that if it's ready for production, and you go ahead and run all the clients, you move all the clients over to the patch version, you shut down the older version of the application, and the patched application becomes, and the patch edition become your current edition and application. All right, let's go ahead and quickly look at how this maximum availability architecture works in the cloud. So we have different database services. We have our Oracle Database Cloud Service, we have Exadata Cloud Service, and we have Autonomous Database. And they have varying technologies that are built into them. All of them are database-aware HA architecture at the end of the day. And in the Oracle Database Cloud Service, you have the choice of single instance, or you can go ahead and choose between rack as well. You can use quick migration via zero downtime migration, or ZDM for short. We have automated backups built in, and you can set up cross-regional or cross-availability domain DR with Active Data Guard through our control plane. Now, we build on that with the Exadata Cloud Service by going ahead and changing the foundation to Exadata with all the rich benefits of performance, scalability, and optimizations for the Oracle database and all the different HA and DR technologies that run within it to the cloud. Very easy to go ahead and move from Exadata on-premises to Exadata Cloud Service. And you have choices. You can do the public cloud, or you can do cloud at customer, or XSCC, as we call it, to go ahead and run Exadata within your own data center, Exadata Cloud Service in your own data center. And building on top of that, we have Autonomous, which also builds on top of the Exadata infrastructure. And we have two flavors of that. We have shared and we have dedicated, depending upon your requirements. Now, at this point, everything's managed by Oracle. And things like a data guard can be configured. We call it Autonomous Data Guard in the Autonomous Database with a simple 2 clicks. You can set up cross-regional or cross-availability domain, DR. And then everything's built, of course, from a highly available multi-tenant rack infrastructure. So it's using all the other technologies and optimizations that we've been talking about. So these are our different offerings that we have. Now, how do you get there? Well, you can go ahead and take advantage of a hybrid cloud approach. This is useful for a migration standpoint or for setting up DR as perhaps a phase 1 to moving into the cloud. You can see that represented here. What we've gone ahead and set up with these different configurations is a DR configuration between customers' premises and one of the OCI regions using the different services. For the most part, Active Data Guard is a technology that we're going ahead and using here. We can see it set up between the customer on-premises in our OCI region for DBCS for both rack and single instance. Single instance, we get bronze automatically, but with Data Guard configured as well, so we're getting DR, so it's somewhat of a mixed approach. And then from a gold standpoint, since rack is already in the picture, Active Data Guard, it's one of our gold variation as far as our gold MAA goes. As we move to Exadata Cloud, whether we're using our cloud at customer or a public cloud offering, is both gold. And it's, once again, it's Active Data Guard in the picture. And we have a hybrid Data Guard paper that you can go ahead and look at on the MAA site, which will walk you through step-by-step how to set these up. And finally, Autonomous. So with Autonomous, we don't use Active Data Guard. Instead, we use Oracle Golden Gate to go ahead and provide the same functionality. And once again, these could be used as beginnings to a migration. Our ZDM technology will even set up Active Data Guard, set up some of this technology for you, and you can stop at a certain point and get this DR environment, or you could complete the migration and move up to the cloud using this different technology. Now, it's not the only option, though. I want to also give a multi-cloud example. So with multi-cloud, you can go ahead and have a database tier running on the Oracle to take advantage of rack and Active Data Guard. And you might have a third party for the other cloud systems, represented by perhaps that pink block that you can see, which could be a third party cloud, which your app tier, your mid tier will be running in. This is a gold MAA architecture. So we have two different regions in here. We have a primary, we have a local standby associated with it. We have a remote standby, and then we also have another local connected to that remote standby. So if we do a role transition, we still have a local standby tied to it. So it's set up even for a role transition. We can roll between the two different data centers. And this is a very easy way to go ahead and get a multi-cloud environment. And then we have Megaport, one of our partners, providing network redundancy as well in that third-party data center. So with that, I will summarize. So high availability disaster recovery, absolute requirements. Everybody should have it. Everybody should think of it ahead of time. We have different blueprints, different tiers of our MAA architecture that map to different RTO and RPO requirements, depending upon your needs. And those may change over time. And finally, that business continuity that we provide with MAA is for both planned maintenance and unplanned outage events. So it's for both. And that's a critical part to this as well. And with that, I will go ahead and leave you with some resources that you can go ahead and look at afterwards at our MAA site, or you could go ahead and kick the tires up in our Oracle Cloud free tier. Thank you for attending.